See, first came the human being. Okay. And the human being observed the nature and asked questions. So far, fine. Human being evolved first. I'll keep it here. First, human being evolved. Then he or she it observed the nature. Then asked questions. Correct? This is what happened. This is how we discovered all the patterns so far, whatever we know. In this process, numbers were built. Numbers were discovered, numbers were defined, numbers were operationalized by human beings. Fine. In the same process, moving forward, your numbers became something like x and y and f of x and all this came. At some point of time, you guys are there? Are you guys following the story? At
Yeah.
some point of time, all this time when you have x and y and f of x and okay, I will even go and write calculus. See, when all this is very important what I'm telling you. All this time, nature and events in nature somehow walked right into a mathematical frame. It walked right into a mathematical frame. For example, you realize you actually have a proof for F is equal to mass into acceleration. Force is equal to mass into dv by dt. That is what is. There is an actual, there is a proof for it. Proof. You following this? Isn't it? Have you not studied this? That there is actually a proof for this. Force is equal to m into dv by dt. Remember? In first PUC, in
Yes,
first
yes,
PUC
yes. I
physics,
know.
first PUC physics, we
Physics,
have
yes.
studied this. Hmm?
Yeah,
Vikash,
yeah, force into velocity.
Yes, sir.
yeah,
Yeah.
you remember this equation, correct?
Yeah, velocity due
With
by
this
time. Yes.
equation, I want you to start think about this because what I'm going to now teach you is the essence. Of course, you are not here to take a nursery kind of class, correct? You didn't sign up for this with me for Maki ka Maki, what is what. This is what the gist is. Somehow nature and events in nature and the events in nature somehow walked right into mathematical frame is what I've written here. Correct? I've written mathematical frame. What is the meaning? Fine, if things are happening in life, if in nature, if force is actually is equal to mass into dv by dt, fine. Means what? Mass multiplied by dv by the rate of change of velocity itself. Fine. But how did we create this algebra? How is nature's event fitting my algebra? Nature is always there. We created the algebra ourselves. How is it fitting here? Did we create this algebra to fit nature, or is nature fitting into our algebra? We created this algebra to fit nature, correct?
Yeah, yeah.
Yes.
To understand the nature, we
Yeah,
only derived the definitions.
correct. You should think like this at this time, at ML and AI prediction level. This is how you should think. We created the algebra to fit the nature there. But as the events get more complicated, this event is not easy to frame it in terms of equations and systems. Here you agree with me? As events get more complicated, not easy to frame it in terms of equations and systems. Simple event, fine. Complicated event, your math is not dynamic enough. Gets more complicated means more stochastic in nature. Stochastic meaning uh, wave in a sea. Example. Can you build algebra for it? Wave patterns in a sea, a number of waves hitting the shore on a particular rock. Too many dynamic things for that particular time, correct? You have a
Yes,
force is equal to mass into dv by rate of change, fine. But still, there are too many other things to consider, which always cannot get into equations and systems. It is too complicated. When such things happen, the only thing you are left with is that's the reason why we wanted statistics. Our main goal has always been about observe nature and get control of or have final control on nature. And the ambition is such that not just understand the past but also use that in the equations and systems and predict the future. So that has always been the goal, and that's why at some point of time the subject called statistics came into the picture. Okay, it came into the picture. And statistics predominantly had three kinds of subsections in it. One is descriptive, second is and third one is prescriptive. Okay, descriptive, inferential, prescriptive. Your descriptive statistics is about it's more about I will need to give you this. It's more about your graphs because you're describing the event. Okay. However, when it comes to inferential, Your inferential statistics is more about meaning of those graphs. Describe and infer. You describe so that you can infer. Once you are able to infer, the only thing left next is to go ahead and tell the whole world. So that is prescribed. Okay, telling the whole world is what do you want? How do you want to see this? Telling the whole world.
We are saying the result to the
The rest of the world.
public domain.
The data was given to you. You used all the techniques to describe it. After description, you saw some pattern. Then you inferred something. You deciphered the meaning of it. After that, when you are good enough, you're convinced that yes, this is the way forward, this is how things are, then you prescribe. Means you tell it to others. Means you tell everybody that follow this from now onwards, right? This is your main uh, flow. Okay, this is how your flow happens. Are you guys sort of getting some feel for it?
Yes, sir.
So this picture you'll need now, correct? Snipping tool, snipping tool. Why we draw that, like this colorful and write, so that when we write, you will get enough time to register it in your mind. If I simply take a PPT and go slash slash slash, I will finish my slide, but it won't go into the, it won't sort of, we should give enough time for the mind to process it. Okay. ए प्रिंसी, इतना इतना लेक्चर क्यों दे रहे हो यार? इतना मुझे ये हो रहा है, पता है, छोटा सा भी पता चलता है इधर। नहीं, वो स्लोली करो ना, मुझे भी आना नहीं चाहिए। आप दोनों के बीच, प्लीज, आप दोनों के बीच में होना चाहिए, प्लीज प्लीज। Okay. So we are going to learn descriptive and inferential. Now the funny part is this prescriptive has evolved into what? Has evolved into
I guess it is machine learning.
machine learning. Yes, that's how life has. So to get here, to make sense of all the stuff that we're doing, we will have to go through your descriptive stats. So let's go here. Let's go back here. So I think now we took some time. Now again, if you read what is statistics, statistics is a discipline of mathematics which helps in determining how true is your guess. A little comfortable now to move forward. Now the question is, can we really calculate how true our guess is using mathematics? Is it possible at least? Is it even possible for us to do this? Yes, we can. If we have sufficiently large amount of data. Data, if you have, then there are techniques, statistical methods to determine the best guess. Okay. Means what? Again, see, best guess means there'll be many guesses. Once you look at the graph, somebody, person 1 will guess, have a guess 1, person 2 will have a guess 2, person 3 will have a guess 3. Now we need to use the system and other statistical tools to qualify which one has more merit. Some will have 90% success, some will have only 50%, some will have only 75%. So percent, what of what percent, that all those things will come into the picture as we will understand it. So can we really calculate how true our guess is using mathematics? We're asking all the honest questions. Yes, you need sufficiently large amount of data. Even if you don't have large amount of data, there are certain minimum amount of data that is required on a particular kind of only then only a certain kind of statistical methods can be applied over there. Fine, that is fine. But eventually, you want to do machine learning type, deep learning type, then you need a large collection of data. Hmm? And collected from an observation, then we can apply statistical methods to determine the best guess. Moving on. Holy. Right. Question. Where does the data come from? The data is generated by observed phenomena. Simply data doesn't get generated. Data will always be there. But if you don't observe it, you will not record it. This observation is also it also hints at the idea of attaching sensors. Sensors like cameras. So important to understand that you have to observe, you have to put camera, and then record it, then your data gets collected. So which one to observe? Now again, when you understand that this observation is also a human attempt, then of course there are other questions which comes up as to what kind of data to collect. This question comes up later. And who will tell? Domain experts will tell it. Okay, what kind of data to collect? Domain expert means if you want to do predictive systems on animals and health, animals and animal health, then you would like a zoologist to help you understand what data to collect. If you want to do finance, then you want a commerce or a finance expert, finance domain person to come and tell you what to collect, right? So these people are all the domain experts. They will tell what to collect. But as a data scientist, as a machine learning engineer, or a statistical analyst, methods of statistics have nothing to do with domain. So we'll understand it later. So now, even a physicist observes the universe. Is it the same? Yes and no. Even a physicist observes the universe. Because why am I saying this? Because I just said data comes from an observed phenomena, is what I said. Correct? Observe Madhura, you will get that. That's what I said. But I'm then saying the physicists, like astronomers, are also observing the universe. Is it the same? Because that is also an observed phenomena. Even an astronomer is collecting data. Is it the same? Answer is yes and no, both. Yes for when and no for when, you'll understand now. Physics helps us to understand the universal laws, patterns of nature. I just told you F is equal to ma. Statistics helps us to understand patterns hidden in the data. Now, this universal laws, nature doesn't change much. It may probably sort of slightly change in terms of gravity if you change the planet. Most of the other things, maybe climatic or temperature or something, maybe drop. It may drop if you move from one time zone to other time zone, you know. So these kind of changes may happen, but mostly your physical nature remains same. But in statistics, it is not like that. Here, data changes based on the phenomena. Always the same thing will not happen. If that phenomena happens to be about nature, yeah, if it happens to be about nature, then it won't. If it happens to be about, if this phenomena happens to be about people, then expect large variations in every new experiment. So that is common. That is going to happen, right? So in this case, in physics case, you are trying to patch patterns of nature. In statistics case, you are going to scan through the patterns hidden in the data. These patterns you want to create an algebra out of. You get that pattern, and then finally you will get some equations. To get these equations, we need to define new terms, new new definitions, and new concepts. So when you come to statistics, like every subject has its own new terms and definitions and concepts, right? When it comes to statistics, you will have to learn these kinds of concepts and definitions. You will learn it. Another interesting, just a sideline question here. What if the data itself comes from a physics experiment? Not now, it's not a human-centric data collection. Some physics experiment itself has generated data. Yes, so you can call even that as something related to statistics, and that is called statistical physics. It's actually it's an actual field. Why I would say this is because uh, you know this electron that we know of, the presence or the conformation of electron is a statistical truth, and nobody has actually seen an electron, because you see, to see something small we use a electron microscope. It is difficult to photograph, difficult to see an electron. I mean, it's counterintuitive to be able to see. But still, we are pretty sure that this electron, whether it is in terms of some wave or matter, it is there. It keeps changing. When you see it as matter, it becomes wave. When you see it as wave, it becomes matter. So this particle duality is always there. This duality is expressed again in some kind of experimental truth. So that experimental truth is your statistical truth. How many times it has happened that you have found it. So if in 10 million times, 10 million minus 2 or 3, if you keep whatever number it is. So if you just say 10,000 times, out of 10,000 times, if you find 9999 times some kind of an electron kind of a thing, then you say statistically there is an electron. Okay, you may not see it, but statistically there is an electron. So that's what your statistical physics is, and it's extensively used. You can go and check for those who are interested. You should check. I mean, you can't being an ML engineer or AI engineer. Don't expect this field is not just that I only know this. This is this is not for them. This field. This field is for those who are like, I want to know everything, whatever it is. If it is interesting, if it is sort of some kind of a pattern and some equation there, I'm interested. If you're that kind of a person, then welcome. This is your field. This is your playground. This is your heaven. Okay. So, but of course, you can't be all the time thinking. But general curiosity and a very controlled and disciplined, scientific, well educated curiosity should be there. Professional curiosity of finding stuff. So, that's what is expected. Now, the question is, how can statistics aid or teach machines to learn? That's the next question. Okay, you guys are following what I'm saying, or lost track somewhere?
Following, sir.
Following. Okay. Machines can learn to discover relationship between different variables. See, machines can learn to discover. They are learning to find out. They are not discovering. They are actually learning to discover the relationship between different variables. Okay, like when you get these patterns, they themselves, of course, you have to reduce the idea of machine learning to, again, what is the best thing a machine can do, a computer can do? Only thing a computer can still do is loop. That's all. Your data structures and all these commands and different methods and everything, they are just, you know, formalities that we will do. Eventually, what are we going to do? We are going to loop through lakhs of data points. But while looping, what are you going to do? What operation? That is the question. You loop lakh number of times and repeat one operation. Can this looping a million times and doing one simple operation can lead to the idea of machine learning? This is what this whole course is about. You are supposed to discover this. How is it that? Because Manjunath and Vikas, finally your computer is the one which is doing machine learning, no?
Yes, sir.
Correct.
Yes, yes,
Manjunath, correct. Your computer is the one. But you already know your computer can only do this digital, your binary computation. There is nothing new. We are not adding new abilities to the computer now. Binary, and that too, what is the most important thing we learn? For loop, while loop, for loop. That's it. Just looping through stuff. And there is looping through stuff, and there is some, eventually you have a loop, then you have an operation, then you have a condition. Correct? You agree with me that this is what eventually we do in any kind of programming language? Forget about just Python. Loop through
yes,
for what operation and what are the exit conditions or entry
yes,
condition or exit. So eventually, even your machine learning algorithm has to be reduced to this only. No other magic will happen. So you keep this in mind always. How it is getting reduced to this then? By all these statistical techniques. Okay. So that is why the connection between this and that. Are you understanding the
yes, sir, yes.
importance of the question? Answer we will come later. Answer we will find. Unless you understand the importance of the question, you will not see the answer. That's the reason. Okay. Okay. Next.
Sir, I think maybe just to summarize, I mean, just to get a good understanding, just to validate my understanding. So, any ML problem will have these loops, operations, and conditions, which we already have been doing as part of Python. Now, we just have to include statistics in that so that we can come up with some meaningful insights about the data and give some prediction. Is that
That's it.
correct?
Yeah, that's
Yeah.
it. I mean, don't take my word for it. Because it is a machine, what else can it do? Correct, no? If
Yes,
if
sir.
a machine is built to do only that, we can't suddenly overnight ask it to do something amazing from it, right? If it's like this, it's like if you have this architect building problem means the problem of not the problem, the project of constructing a big apartment. So you will find, you'll bring people and you bring the bricklayer. So now the bricklayers work. What is the bricklayer? What does he know? He doesn't know architecture. He doesn't know plumbing. Nothing, right? He knows how to put a brick on another brick, and before placing another brick, he has to cement something. To apply a paste, a layered, controlled layered paste of cement, whose proportion also probably he is not bothered about. So eventually you have to use these people and control the number of people working here and which project, which place. Then only you'll get the whole thing done, no? Eventually, it is about putting a brick on another brick. That's what makes an apartment, correct?
Yes.
Right? So, okay, that's when
So the machine will understand the pattern itself, or does the human communicate the pattern to the machine? So how does that process work?
machine or a pattern is the model. Machine will derive the pattern.
Okay.
So that if the machine is able to find the pattern, if you are able to find the pattern, you are learning. If machine is able to find the pattern, machine is learning. That's machine learning. Oh,
Mhm.
yes, such a nice, very simple, yeah, correct, right? This is the first time
Right.
I also arrived at such a simple. If you are able, you see nature, and if you are able to, derive patterns, then you are learning about that phenomena. If the machine is able to do it, then it is machine learning. Now imagine how great human mind is that you are able to make a machine learn looking at the data, and it is able to learn more than what we can learn, and together there are so many incredible things that can be achieved. Great, right. Makes sense, huh, Vikas?
Yeah.
Yes, sir. Yes, sir. Absolutely. Yes.
Correct. So machine learning algorithms use statistical concepts to establish relationship between data. Cool. Now we come to business end questions. Okay, all that was okay, setting up the scene and all that. Fine. Now we come to the business end of the questions where we say, are all data just numbers? Whatever data, whatever the machine now takes in our computer, what do you feed in? Only numbers are we feeding? Only binary numbers if we feed, we'll get something about the phenomena. Good question to ask. I hope you are appreciating the questions here. Are all data just numbers? Data are of different types: quantitative, qualitative. Not all data is just about a number. Data are of different types: quantitative, qualitative. Quantitative has a root word quant. This is quality. How do you express quantity? In numbers, right? Data that can be measured with numbers, your integer, your real numbers. So take for example any quantity. There are discrete quantities, there are continuous quantities. Discrete quantities means uh, your integers, numbers which cannot be broken down into decimals, right? It's either a 1 or a 2 or a 3 or a 27. It cannot be your 27.2, but in continuous it can be. Here I'm saying under discrete it cannot be 27.2. Okay, here under continuous you can have 3 also and 3.2 also, fine. That's the meaning of continuous. But the question is, how did this come into picture? Like, what is why it is important for us to see this separately? Because we are now see interested in this. You should always have this context clear in your mind. This is the actual context. Okay, data quantitative discrete, then there is data quantitative continuous, then there is data qualitative category, qualitative ordinal. You should have this perspective. Now the data, one more important perspective above data is the event which produces the data. Now when you take this event which produces the data, you can now even say the event itself ensured or event itself was the reason why you only got discrete numbers over there. Like you take for example, how many items purchased online in 2023. How many items purchased online in 2023 is the question. The answer will always be discrete only, right? You don't purchase a decimal number. You don't purchase a decimal number, right? Correct?
Yes.
Right?
Yes, sir. Yes,
Same
sir.
like that, if you want to fill in some petrol or purchase milk or something, if it is, of course, if it is openly available, something which can, it's not boxed or packed, then it comes to in decimals also, right?
Yes.
So that is the number that this even when I'm dividing this data into different types, that that classification is based on what? On what basis are you classifying data? Question, right? If I'm classifying people, on what basis you can ask, correct? Simply, if I like this person, if I like all these people, I should say you guys come here. I don't like you guys come here. Now there are two kinds of people. Can I do that? Every classification is based on a reason, right? Or based on certain parameters. In my case, the data or different kinds of data are based on the event which produces the data. So the event, if your observational event was capturing quality of the event, such qualitative questions where words are used to express or nominate. Let me just, before I forget, I don't want to, how do I do it? Print screen. So quantitative, discrete, continuous numbers and moving numbers. Qualitative, you're asking questions. You're asking how was it? How good was it? You know. So all these, if somebody asks you how's the tea, you will not answer in two, three, four, right? Directly, you will not rate it. It's a good, bad, okay, nice, not bad, All these are words, right? Words are used to express or nominate. If you are just nominating, then it is categorical. If you're sort of expressing some emotion, then it is ordinal. What is the meaning of that? Again, we'll have to see. Category. If I ask you guys, um, how many, what kind of movies you like? I'll ask you a question. What kind of movies you like? You will tell me,
Action,
yeah,
Like thriller, science
violence,
fiction.
you
sensor,
see, I'm writing that thriller, action, comedy. I'm writing
suspense, comedy.
categories. Now there is no way I can rearrange this, right? Putting a thriller first, action second, comedy. Simply, I cannot rearrange and say I will put this first, this second. Simply, if I cannot say on priority, I will try to suggest thriller movies first or action. You may have said it first. Maybe it came to your mind first. Because it came to the mind first, we wrote first. Otherwise, there is no absolute rationale in you writing it first. Unless unless you try to X deliberately order it, saying that my first preference is this. My personal preference, I would first, any given day, first suggest me a thriller movie. I would, there is 99% chance that I will enjoy a thriller movie, and maybe some kind of comedy I may not like, some kind of action I may not like. Okay, so like that, you will have personal preferences where then your order will come into picture. If it is only a nomination, it is just a category. But if the categorical numbers have hidden order in it, where data used to describe, for example, here let's say data, kind of data that gets collected when we ask you to, tell what kind of laptop you have, what company's laptop you have. I think everybody ask your families, friends, and everybody, then you will make a list of it. Then you also make a list of the laptops and you take the price also of it. So this is going to be some 12K, this is going to be 40K, this is going to be 81K. Now you have a rationale to either sort it ascending or descending. Simply no sorting. Okay, simply no, without any reason you cannot rearrange it. That's what I was trying to get at here. So what I'm trying to say is at this point we'll stop it here. What is the 8:39? Okay, fine. Okay, we have time, no, till 9.
Yes.
Okay, so what I'm trying to draw here is another important lesson called reference systems. Any kind of prediction is though is after a long time, but any kind of measurement cannot happen unless you bring it to a reference system. That reference system is your Cartesian coordinate, and here is your x, this is your y. Okay, anything you take, your quantitative data, quanti quantitative data, where I ask you guys, I ask you and your friends, everybody, how many items did you purchase from online last year? So let's say I ask all my 150 students how it happened. So everybody is going to give me some number. Somebody will be 12, somebody will be 20, 12, 21, 48, 72. Like this, everybody is going to have some different numbers. And there'll be a name associated with the name 1, 21, name 2, 12, and that. So now it actually sort of is okay for me to now take this from 0 comma 0 and build it till, let's say, it depends where it goes, let it go. So wherever it goes, let it go. We'll only have to sort of decide the unit as to how much is the basic unit between one step change. So from here to here, if I want it to be 0 here and 5, 10, 15, 20, 25. So each interval is now has a standard difference. That is a common difference is there. Right? So we set it up like this, and then we can bring this data here. We can say N1 is somewhere over here. We should be doing this actually. 5, 10, 15, 20, 25, and you can bring your 21, right? Somewhere 21. Somewhere you have 21 here. Oh, so you have 21 here somewhere. So bring your N1 here. So that n1 is at this position 21. Okay, so this is n1 already. So this cannot happen when you just ask the question what kind of movies you like. Simply thriller and action, comedy. We want to measure this also, because without measuring we don't ask questions. We ask questions so that we want to measure. Otherwise there's no other reason for data science experiments, right? But these things, how will you bring it here? Unless you have a system, unless you have a method. Yeah. Okay. Unless you have a method for it, how will you bring it to the reference system? So the key takeaway here is, remember, I may want to write this in a much harder. No, no reference, no measurement. And no measurement, no. Who will fill up the blanks?
No data analysis and no prediction eventually.
Correct. No prediction. Okay. So always you should be worried about what's my reference, what's my measurement, or if I'm able to measure, the once the measurement happens, then your algebra will kick in, and algebra will, machine is going to make this pattern happen, and then prediction comes up on its own. So that's the reason why we went here and we tried to define correctly different kinds of, there's a quantitative, there's a qualitative, there's a categorical, there's an ordinal. These directly come and fit in. That is fine. These continuous numbers are there that directly are, you know, easily what do you say? Easily measured, right? Directly to the imported to the reference system. These categorical data don't usually get there. Some categorical data can get there, some cannot. But those who can will definitely be first need to be converted to ordinal, then it comes here. Okay. In that, in your continuous data where there are continually moving numbers, there is then the question of intervals and ratios. Okay, so you had that interval here, right? We were just trying to give it a scale. So this common interval, whatever is there here.
So interval between how frequently it's occurring. Correct, Allah sir?
Correct, correct. And your ratio is more like, if the pattern is a little different, where it is following some kind of 1:3 ratio. You see this one, then the second one is 2, third one is like this, fourth one is like this, right? So you see one portion, then the second portion, then the third portion, fourth portion. So you have sort of a ratio over here. So as you move forward, it is one extra before the previous one. If you want to take,
Yeah,
you know,
ratio is increasing so that we can understand through the
it's
pattern.
scaling into some, there is a scaling here, right? That's when you get there's a scaling factor that comes into picture, right? So that's when the ratio comes up. So when it comes to continuous, you will find all these kind of things happening. And these happen only because if you can go to the reference system. And ordinality also can go into references. So you will eventually learn this. You will eventually see this, and of course, that's why I'm recording this so that you can watch this again and think, pause and think, pause and think. If you do this, I think it will then work. See, I'll have to be, we will have to be sort of honest about the field itself, because prediction and machine learning and all that is a very advanced technique, and it is not a subject. It is a very clever use of many subjects. Very clever use, use of many subjects, like what? Many subjects like computer science, statistics, algebra, domain knowledge, right? It is a clever use, right? So you will have to sort of get into that mode of very research kind of a research scholar kind of pause and think and move forward kind of a mode. So I'll hope we can again get back to this video what we've recorded, and we can do the needful. Now let's check this interesting stuff. Types of statistical method I told you, no? Of course, I have not put the prescriptive one here. I'll reference the prescriptive one here once we start seeing the slide. Two kinds, descriptive and inferential. Descriptive talks about how does it look. It means data. So how does it look? That is descriptive statistics. What does it mean if it looks like this? That is inferential statistics. How does it look? What kind of questions are around how does it look? Means what? Where are the points relative to each other? And this comes up when, let me also draw in the context. Suppose you have now drawn, plotted something. Suppose you plotted something now. Huh? Some data, some for some x, some y. Let's say this age, x is age. Let's say this y is salary or something. So you have plotted this data over here. I start asking these questions here. Where are the points relative to each other? What are the most common points that are occurring? How often do the data points occur? What is the spread of the score look like? Spread, how spread out it is. Are they near to each other? Are they very far from each other? These kind of questions are the ones which are describing the data. Inferential statistics, how do I prove the theory I have about my data's behavior? Inferential. See, after describing the data, then you create a guess or a theory or a hypothesis. Now the question comes up. How do I prove the theory I have about my data's behavior? Then, next question. How can I use my sample to make predictions about the population? Because my theory was on the data that I collected. Okay, let's say I have data that you collected, the data that you collect is collected data. And the data that is out there in the real world is real data. Which one is higher? Real data will always be higher than collected data, correct? Or you can say collected data will always be less than real data, correct?
Yes, sir.
So if the
So
theory
it
and the
will be
guess,
predicted data, right? Predicted data will always be less than real data because collected data is nothing but the real data, right?
no. Collected data is only a sample of the real world data, no?
Oh, okay. You mean sample. Okay, okay, understood. Yeah.
So whatever data you collected for that event, for a particular event, that actually has a lot of data, correct? We don't even know how much it is. Whatever we've collected, we have just decided to, we decided let's just take 10,000. But in that, the population can be many. We don't even know the actual number on the figure of the population, correct? So the guess on the collected data, which is so much less than the real data. How can this guess on the collected data you fig okay, you made an inference on the collected data because you used this collected data and you did all this description. Now on this
Can we
collected,
one interrupt, Vijay? So can we give a real-time example like pre-election report? So what this media does, they will collect the data, but the real data is always different. So like what election is happened just in 5 election data.
absolutely, that is the
Correct. Exit
exact, that
nothing.
exit poll, yeah.
Exit poll, yeah, pre-exit poll.
Yes. So uh, you will take data from Bangalore North, but they will say there is a, according to the reports, according to statistics and reports, Bangalore North has a drift towards a certain kind of a party. They have not asked everybody. They have just asked all the representations statistically how much ever is required to ask. They'll do that. Hmm? So okay, there is no point in going into the same area and asking everyone. They know that generally in that area, ask this much percentage people, then we'll get a hang of it. They know, right? So that has an actual, say, exit poll is not directly statistics because exit poll and this political statistics, right? It has its own hidden domain there. People know something, certain things which people don't know, other people don't know, like how much to ask, where to stop, how to differentiate, how to cluster different kind of people. They know, with experience they know it. Okay, that's what party workers are doing, thinking about. So it's the whole science has evolved now, but eventually it is statistical only. So what your collected data's guess, how can you trust that on the real world data? Means you, uh, you know, uh, just because exit poll is saying that you will win or a particular party is going to win, will the party leader or somebody already order, cars or sweets and everything in before only beforehand because they have to celebrate and party, right? So will they order? After winning only they will do the ordering, right? No matter what the guess is still waiting for the final result, right? So, but
Yes, yes,
sometimes in
yes.
life
That's
we
the real
can't
data.
wait for the final result. Sometimes here we are waiting, but in real life, what if there is no final result? I mean, you have to take a step now. In future, you will get paid or you'll succeed if it goes true. Like if you are gambling or you're predicting share market prices, or that's what you buy when you buy a share market share, particular company's share, not because you already know it is going to peak. It's a gamble only, right? Like that also career. You already know you'll become a great machine learning engineer. You don't know. But you already know you're already going to work as NLP expert or Gen AI expert tomorrow. No, some kind of guess you are also doing. But in statistics, whatever guess you did on your collected data, how true or how much successful you will be on the real world data. One, you had a theory. You had a theory. Theory is here. Don't forget this. Your theory is here. Your guess is here. That is your theory. Guess is on the collected data because you can't guess on the real data because you don't have that real world data here. All the data in the world, that is this collected data, is your sample. This real world or real world population data is your population. So on the sample you can have a guess. And maybe your guess is very strong also. It is according to the data, it's really giving a very clear indication. For example, let's take an example. You have same age and you have salary. Okay, now I'm going to draw this data pattern for you. So this is your data pattern. Now, what do you feel about age and salary, your inference? You see, already you're saying with age, salary increases. Can you not see that? You described the data, but can you not infer that which age salary is increasing?
Yes, 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 yes.
Correct. This is a trend, no? This is a trend line. You're inferring that because it is looking
Yeah,
like that. According to the description, you're seeing. But how many data did you collect to do this? Maybe you did all these data points on 1,000 people's data. And when you finished your inference on your sample, now you want to, what did you draw? What is the final takeaway here? The final takeaway was salary increases with age. This is your final takeaway from this. This is your hypothesis. When you have 1,001th person and you come to know that the person is around 37, then you have another 1,002nd person, you come to know that person is around 42, and you have to make a quick decision as to whom to sell your new Creta car to. Whom will you, based on this?
One with 42 years of age.
Yeah, because you already prescribed that. Your own finding you're prescribing to your new problems. But then, is it really going to work in the real world? That question is, how can I use my sample to make predictions about my population? So that is what this one will do. This is your guess. How do I prove the theory? How about my data's behavior? Proof is going to be here. And how do I sample it? Is going to be here. So let me not, let me just first take a print screen of this. Should have happened. Why? I don't want to lose this. We'll finish this and we'll end, okay? This is another three more slides are there. So after thinking all of this, now you are looking at this stuff. Where are the points relative to each other? Are called position of the points. What are the most common points? Are called the central tendencies. Then how often? Frequency. How is the spread of the score? Variation. How do I prove the theory about my data's behavior? It's called hypothesis testing. How can I use my sample to make predictions about population? It's called estimation. We'll get to, of course, your estimation will not go to the level of estimation and all. but we can definitely go till all of this whole descriptive statistics and hypothesis testing and these kind of tests, Z test and T test, we'll not get into because it's purely for sampling and purely in your you know clinical statistical analysis. But most of this hypothesis testing and p values and all that, yeah, we will have to because we want to. There's more actually. There's more important stuff here that will be used in evaluating your machine learning model. Now, coming to your position here, quartile rank, percentile rank, coming to what are the most common points, central tendency, mean, median, mode, frequency, counts, and percents. And these are the stuff, these are what names given to those main functionalities, right? Here you have hypothesis testing. In hypothesis testing, there is Z test, there is T test, and depending on different kinds of data you have, different kind of whether you have a numerical data, whether you have a categorical data, depends, right? The data is data, event is event, but what kind of data there is also matters. Based on that, your changes, your tests change. And here also in estimation, you have different kinds of estimate. A parametric estimate based on pure direct input parameters. Then there is confidence interval. So like, can you be very confident about a particular interval and in other ranges, you may not have that kind of confidence in prescribing a certain thing. So like that, you'll start thinking. So all this, the whole stuff that we did today eventually boils down to this picture, and I hope you have gained a little today. Right? Any questions so far?
As of now, I don't have anything. Let me go through the last part, whatever you showed in the 14th page. So I will review it. So and if there is any